Hello, welcome to the third day of this unit. Today we're going to learn about changing the forms of quadratics. Now, quadratic functions can come in different forms. They can come in the general form, the vertex form, and the factor form. And each is useful in a different way. Let's start with the general form. The general form is y equals ax squared plus bx plus c, or you could say x equals ay squared plus by plus c. This is useful because it tells us the x or y intercepts, depending on what this is solved for. So in this case, it gives us the y-intercept. So our y-intercept is at 5. The problem with the general form is it doesn't tell us much else. We have no idea if it comes down like this, if it comes down like this, if it comes down like this. That doesn't work. Well, whatever. Hopefully you can see that all we know is that it's going to pass through 5. Now, if it's flipped around and it's solved for x, now we know that's the x-intercept. So my x-intercept is at -3. However, I don't know anything about this. It could come like this. It could come up here and just hit it. Could go through and back. We have no idea. All we know is that it passes through that point at x equals -3. Now, vertex form. Vertex form is nice. This is written in this form. It's useful because it tells us the vertex and also the scale factor. So A we call the scale factor. So in this first situation, the vertex, HK is the vertex, so 3, 4. So that means I move to the right 3, up 4, and then we have our point. It goes up because of maybe I should fill this in. 3, 4 is my vertex, and the scale factor is this number in front, which is 1. Now, if that's positive, our parabola is going to go up, and it's just going to have a scale factor of 1. Now, a scale factor of 1 in a parabola. Let's go on a new sheet for a second. A scale factor of 1 will mean that if I take my normal function y equals x squared, if I go to the right 1, there will be a point, I go up 1. If I go up to the right 2, now I go up 4. If I go to the right 3, now I go up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright. So then it would be the same thing on the other side because parabolas are symmetric. And then we can draw our graph. Now that's if the scale factor is 1. If the scale factor is 2, so I'll do y equals 2x squared. Instead of going to the right one up 1, I go to the right one up 2. Instead of going 2 to the right, I'll go up 4, I'll go up 8. So this one is increasing much faster. So that's 2x squared. And third would just be up to 3, and then 9. So, or 12 actually. So that's scale factor. All right, so now let's look at this. X equals 2y minus 1 squared minus 6. Now this is where things get confusing. That minus 6 is actually where we want to go in the x direction. So this moves it 6 to the left. And now in the parentheses, it goes in the opposite direction that we think. So it should go down 1. Now so our vertex is -6, -1. Our scale factor is 2. And since that's positive, it's going to open to the right. So instead of going up 1 over 1, I go up to the right 2. Down 1 to the right 2. Up 2, I'd go to the right uh, 8. So that would get me to 2, and then down there. So now we draw out our graph, and it looks like so. All right, now roots or zeros or solutions, three ways of saying the same thing, are of a function are where the function crosses the x-axis. A parabola can have 2 roots if it looks like this. It could have 1 root if it comes down and just touches and turns back around, or it could have 0 roots if it looks like this. It turns around before it hits the axis. Now, there's a zero property that says if you multiply several numbers together and the product is 0, then one of the numbers must be 0. So 2 times 5 times what equals 0? Well, that has to be 0. 4 times what times 3 equals 0? X has to be 0. 2 times this times 5 equals 0? Well, what's going to make this 0? 1. 1 minus 1 equals 0. If 3 times x plus 4 times x plus 2 is equal to 0, x equals negative 2, and x equals 4. That's a horrible equal sign. Those two values will have this function equal 0. So we use that when we're dealing with factored form. Factored form is useful because it tells us the roots and the vertical scale. So in this situation, the roots are going to be 2 and negative 6. The scale factor is 3. So let's draw this out. 2 to the right, negative 6. 1, 2, 3, 4, 5, 6. Now, the scale factor is 3, so this will go way down and come up. It's going to go way down and then come up. Now, if I want to find the coordinates of the x-axis, or the vertex, it's not as easy as looking at vertex form, but we can do it. And how we do this is we know that parabolas are symmetric. So the vertex has to be between these 2 points in the x direction. So between 2 and negative 6, if I add those together, I get negative 4 divided by 2. So negative 2, being the average of 2 and 6, or 2 and negative 6, is going to be where the x value of my vertex is. So the x value is negative 2. So if I plug in negative 2, negative 2 minus 2 is negative 4. Negative 2 times 6 is 4. So now I have 3 times 4, or I guess 3 times negative 4 times 4, which is negative 48. So this point down here is negative 2, negative 48. All right. Now, if I have x is equal to 2y plus 1, y plus 3. Now, roots would be a bad term. Usually, roots, we just talk about hitting the x-axis. So what we should call this is our y-intercepts. The y-intercepts on this will be negative 1 and negative 3. So negative 1 and negative 3. Now the scale factor is 2. So we know the y value has to be between here. And this should be pretty easy for folks. Negative 2 is going to be the y value of my vertex. Now if I take negative 2 and plug it in for y, negative 2 minus 1 is negative 1. Negative 2 plus 3 is 1. So 1 times negative 1 times 2, that would be negative 2. So I go to the left 2, and then down 2, and now I can draw my parabola. All right, now if we want to convert these to general form, all we have to do is do our foiling. So this would be 6x squared plus 8x minus 3x minus 4. And we can take it one more step and combine the x's. So 6x squared plus 5x minus 4. So now we went from factored to general. Now if I want to do this one, you can multiply the 2 over one of them first, or you can multiply those out. I'll do the right hand side first, so this would be y squared plus 3y minus 7y minus 21, which is equals 2y squared minus 4y minus 21. Now multiply that 2 over the parentheses, so we have 2y squared minus 8y minus 42. Now if we want to convert this to general form, we just have to square this, and we know that's a nice perfect square, so we know the shortcut. X squared plus 10x plus 25. Now we just have to add those two last numbers to get 28. Now you try this one on your own, see how it goes. Hopefully we got 3 times y squared minus 12y plus 36, which will be 3y squared minus 36 plus, 36 times 3. I should know that, but I don't. 108. So x will be 3y squared. This is a 36y plus 103. All right, now we need to convert to factored form. So y equals x plus 2, x plus 3. Computer's going a little slow here. And down here, x, what two numbers multiply to 18 and add up to 11? That would be 9 and 2. Now if we want to convert this to vertex form, this is what we were doing yesterday. So we have y equals x squared plus 6x plus blank plus 11. What needs to go in there is a 9 to make it a perfect square, so we have to subtract 9 out there. So it would be x plus 3 squared plus 2. In this one, we would do y squared plus 8y plus something. And that number has to be 4 squared, which would be 16. So we have to subtract a 16 out there. So it would be y plus 4 squared minus 13. Now, if it looks like this, we have to get the 4 out of this. So we take a 4 out of the equation first, so it's x squared plus 6x. I have to add a 9 here, but really I'm not adding 9 to the right side. Really I'm adding 36, so I have to subtract out of 36. So it's going to be x plus 3 squared minus 35. All right. Hopefully we understood this. And now if I want to do this one, where I want to just solve generally, the first thing I do is divide each section by a, or no, let's do it like we did our previous one, where I took a to the outside, and then it would be x squared plus b over a x plus something. Now, we have to think about what we have to add here. So let's go down one more step. And what I would put in here is plus b over 2a x, because I cut this in half to go here. And actually I wouldn't even leave x, because we end it here and square it. So our last term is this whole thing squared, which is going to be b squared over 4a squared. So if I add it in here, I have to subtract it, minus b squared over 4a squared. So that I just add this along, plus c minus b squared over 4a squared equals 0. So now let's move these two things to the other side. So I would add b squared plus 4ac and subtract c. So I'd have b squared over 4a squared minus c is equal to a times x plus b over 2a squared. Now let's add these two together. To add them, what we need is a common denominator. Our common denominator here would be 4a squared. So if I multiply the bottom by 4a squared, I have to multiply the top by 4a squared. So I can combine them to get b squared minus 4a squared c all over 4a squared equals a times x plus b over 2a squared. Now, I just noticed a small little error that I made because things weren't going exactly as I had planned. I noticed that here, when I put in the b squared minus 4a squared over 4a squared, I didn't multiply that by the a when I found my value over here. And when I multiply it by a, it actually just turns into 4a in that denominator. So then it looks like this, which is more where I was going. Apologize for the mistake. Hopefully some of you caught that. Um, Now here I divide both sides by a. So x plus b over 2a squared is going to equal b squared minus 4ac. If I divide this section by a, that's like putting another a in the denominator, so that would be 4a squared. Now I'll take the square root of both sides. So it'll be plus or minus b squared minus 4ac all over 4a squared is equal to x minus x plus b over 2a. And now I subtract that from both sides. So I have negative b over 2a plus or minus the square root. Now this we can break it down into two sections. B squared minus 4ac all over the square root of 4a squared. That's just going to be what x equals, which is the same thing as negative b over 2a plus or minus square root of b squared minus 4ac all over 2a, which we have negative b plus or minus the square root of b squared minus 4ac all over 2a. And hopefully everybody remembers this as the quadratic formula. Now all the quadratic formula is a shortcut for solving for the perfect square. If you can do this, you can, it's this, the quadratic formula, having trouble finding my words, the quadratic formula is just doing completing the square. So completing the square is the same thing. All right. Now your homework for tonight is worksheets. So hopefully this helped you work your way through it.